Okay, now here at the bottom of page 2 of the notes for 9.4, looking at example number 42. And what's different here? Well, in the previous example that's off screen now, we had one fraction under one big radical. Now we've got the radical already split here. And again, we're going to look at this in two separate stages. It doesn't change how we're going to deal with the problem, it just has a different starting look to it. Our goal here is still the same. In the end, we don't want any radicals in the denominator. So sometimes it's easier to start by simplifying what you actually see here. Is there anything we can make better? And in fact, there is. When you see 125, you should start to get familiar. Oh, there's a 25 in there. 25 times 5. That's going to make the numbers on the bottom easier to deal with. So let's go ahead and simplify this out. That radical 3y, there's nothing we can do with it right now, so it's going to stay the same. It's just going to remain radical 3y all the way through this. Okay, and I've already worked this problem out. That's why I know I've got 3 steps here to get to where I want to go. Again, I'm showing more steps than probably is necessary, but I'm just trying to make as clear a picture as I can of what's happening. So what we're doing is we're trying to split 125 into something times something where one of those is a perfect square. And in this case, 125 can be split into 25 times 5. And you've got two things multiplied under radical. You can split that into two radicals. You've got your radical 5 and you've got your radical 25. And the purpose here was to get that radical 25 split out because we know what that answer is. That answer is just going to be 5. And we still have our radical 5 there as well. Why is it 5? Well, because radical 25 is 5 times 5, which is also 5 squared, and there you've got the square root that undoes the squared, and that's just equal to 5. So that's where we got that. And the purpose of attempting to rearrange what we've got here allows us to have a nicer, smaller, so to speak, denominator to try to rationalize. So at this point, we're ready to rationalize. We could have done it right from the beginning and multiplied top and bottom by radical 125. But then you've got a bigger number to try to split out up top. You're then trying to cancel, see if there's any matching factors. Sometimes it's just easier to do as much simplification first before you're ready to rationalize. Okay. So here's the rationalizing part on this second row. Up here we did the simplifying, and now as we go across you'll see the rationalizing. So I'm going to go ahead and copy what we have here. We have radical 3y in the numerator on top, and 5 radical 5, or 5 square root 5 on the bottom. And so as we look at square root of 5, that's what's getting in our way from having a rational denominator, a denominator that we could measurably break up something into equal pieces, and that's what a denominator does. That's the name of the fraction. 1/4 means that I have something that I can divide into 4 equal parts. Well, 5 radical 5 is not a rational number. It can't be measured because 5 has a non-repeating, non-terminating decimal. So we need to get rid of that radical 5 in the bottom. But we just can't nix it. We have to, in a sense, move it around or manipulate it. So we're going to multiply both top and bottom by a value of 1. And you look at the radical in the denominator, and because it's just a single radical and it's just multiplication involved, we're just going to go ahead and multiply by that radical. In this case, radical 5 over radical 5. And what we get to here is the top piece is going to become radical 3y times radical 5. And we'll just deal with the top for a moment. And because it's radicals here, you can multiply inside the radical. You can smush those together. So it becomes one big radical 3y times 5. And finally, radical 15y. And 15 can't be simplified any further. There's nothing, there's no perfect square inside of there as a factor. Y can't go any further, so it's just going to stay that way. On the bottom then, however, we've got a 5, and this 5 is just going to follow us all the way through. But what we're really focused on is that 5, that radical 5 times radical 5. So this radical 5 times radical 5, essentially that is going to become, you can mush those together just like we did up top, and you get 5 times 5, which is going to give you a radical 25, which we know to be plain old 5. So in that second step here, we still have our 5 from the beginning of it, back up here when we simplified. Our radical 5 has been multiplied by another radical 5, which gives us a radical 25. And then we know that answer to be just plain 5. So then it becomes 5 times 5. And then our final version is radical 15y over 25. And again, resist the urge to try to cancel when something's in a radical and something's not. Those are not things that you can cancel because they're two completely different types of numbers here. Radical 15 is not 15. So it is a different number. It's slightly less than 4. It's probably like 3.8 or 3.9, but the decimal does not end. It goes on and on forever. So it's not divisible by 5, and so there's nothing to cancel here. So that's done as is. Okay, and then you can try the one that's on the bottom. And what's different about this example is at the top we had the entire fraction sitting under a radical to start. In our second example, we had a radical over radical. In this last third try example, you've just got a radical on the bottom. And again, think about what we've done here in these examples. You want to simplify as best you can first, so you get as small a number to rationalize as possible, and then you can work on the rationalizing. So the suggestion here, try to simplify radical 50 first, get it as small as possible, pull out any squares that are square roots, perfect squares that you're able to take the square root of is what I'm trying to say. Okay, so copy what you've seen on this page, talk someone through it, note any questions, bring in the class, and then pause the video so you can try number 28 on your own. Okay, and the final answer here that you should get is 3 radical 2 over 2. Once you've rationalized it, you've got a nice number down there on the bottom, and you've also done all the simplification that you can here. Okay, so make sure that you bring any questions that you have to class, and we'll take care of you there. Okay. I'm just double checking my answer here to make sure that we're totally right on. Maybe we'll walk through this one in the notes just so I can double check my own work here. Let's do that together. So simplifying across, I'll start with the red pen here. I saw a 50 could be broken into 25 and 2. And then on the bottom, that gives me just plain old 5 radical 2. So that's a simplified action. I could go one step further, and I get 3 over radical 2. And then when I rationalize, so now I've got 3 over radical 2, and I rationalize by multiplying by radical 2 over radical 2, because I'm really multiplying by 1, and then that becomes 3 radical 2 over radical 4, which is just 3 radical 2 over 2. So, good. I was just a little hesitant there because I did some of that work in my head as I'm looking at my notes here, and I just wanted to double check. So, there's that one worked out for you. And again, if it didn't make sense, please bring it to class. I'm more than happy to help. That's what class time is for this term.